Murphy is your good friend. So you try to understand what could go wrong and how it could be easiest detected, because you don't want to measure 35 different dimensions to figure out that one thing is wrong. We would like to introduce to you as a designer, engineer, or entrepreneur what you can do to plan your quality control process, because we believe quality control needs to be proactively planned, step by step, rather than just checking at the end and then finding out that a certain percentage is garbage. Hello, my name is Florian Heike, CEO of Celinius Company Limited in Taiwan, with more than 20 years of manufacturing experience. Today, I want to talk about the verification of the parts that come out of the tool compared to the drawing and how this can be assured in quality manufacturers. When we have a 3D model, we have beautiful straight lines. Everything looks great. The screws fit and you can zoom in and you see the things. Well, once you have your tool and you get parts coming out of the tools, hardly any straight line is really a straight line, because the cooling process of the material is not even. And when that cools differently, you get tensions in the product, and a tension will lead to deformations. You need to verify whether the product that you get out of your tool, how it differs to your model, and whether the difference matter or don't matter. Part of the design is to define in the beginning what surfaces have to be exact, very precise, and which surfaces may just have to be beautiful, and how to verify that. Even though you have these fancy 3D measurement equipment, that's good for the initial design consideration and to fix your mold, it's absolutely impractical for your serial verification. So for serial verification, the key is to build very simple tools to check it. Even you find out that things are not perfect in the beginning, that's not the end of the world. You're often able to correct small defects by doing some mild modifications. That's what an experienced mold maker can help you to suggest. But then again, how to verify it. Because even though your mold is perfect now, it's not going to stay like that, because the mold will get worn, and so the mold will degrade over time. And how it degrades may matter or may not matter, but how to install checkpoints in your manufacturing process so that you detect these deviations early enough without producing garbage, basically. Because an aluminium part that comes out of a die casting process and you detect it, you remelt it, okay, that's manageable. But if you spend an $8 paint on it, on the surface, and it's beautiful, and then in the end you realize, oh, it's out of dimension, I can't use it, that's an expensive endeavor.
So Florian, we heard you talk about implementing quality as part of the entire process, not just at the end. But the people watching on YouTube, how are they expected to do that when we're over here in Taiwan and they're back home in the West?
Murphy is your good friend. So you try to understand what could go wrong and how it could be easiest detected, because you don't want to measure 35 different dimensions to figure out that one thing is wrong. You want to measure the correct dimension that will tell you whether it went wrong or not. It's called an FMEA. You do a failure mode evaluation analysis. You determine what could go wrong, and then you define the control, what goes wrong, and how to detect it early. Because the earlier detect a mistake in the process, the easier it is to A, correct it, and B, avoid having a lot of value-added processes put into them that in the end are useless.
How do you go about helping your customers through this process here in Taiwan?
We are reviewing those quality control procedures, so we are interviewing with our customers in detail what are really the critical features of them. And then we go back to the root cause of where it goes wrong, and then we also define how to measure them. Because although we have these super fantastic equipment here, it's slow. And in reality, when you have a serial production, you're not going to use that tool to do this. You want to build a very simple inspection tool, which will give you a very clear answer. Good, bad, or at the borderline. And those inspection tools are part of the project called Inline process control. And we'll provide this as part of our mold consulting business. Okay, for instance, for die casting, we have deformation and shrinkage. So 1 or 2 measurements to detect those 2 defects are usually enough right when the product comes out of the machine or before it goes into the next post-machining process. setting these parameters and making them part of your quality control are crucial and highly recommended to avoid having a poor yield at the end. One key features on die-casted parts are the accuracy of mounting holes that are connecting to other parts of your machine. 龙先生，你可不可以介绍你把这个洞的大小你这么练？
量测完这个孔径之后呢，再找相对应大小的筛龟，然后放置里面去正确的量测它的尺寸。
And then you have one bigger pin that should not go through. 所以你要一个比较大的，对不对？ Okay, he just explained that because of the die casting process, you tend to have a draft angle, meaning the hole will not have the same diameter all the way through. It will be a bigger diameter at one dimension and a smaller diameter at the other one. This is because you have to be able to open the mold. So you see, here we have a bigger pin, which would not completely go through. It will only go through a section. And now you know that your whole dimension is somewhere bigger than the smaller one, but smaller than the bigger one. And these ones have dimensions written on those pins. And now you can determine that what your actual hole dimension is and whether it meets the drawing or not. Now we are checking linear dimensions. The easiest way to check a linear dimensions, like the width here of this part, is using a caliper. Caliper also needs to be calibrated once a year. So 龙学生，你可不可以给我们看怎么试这个尺寸？它是58.59 58.59 millimeters. Well, this is reasonably accurate, but for some dimensions, not accurate enough. So there is another tool if you want to have it even more accurate. So he's now using a so-called micrometer screw, which in the name tells you that you can measure down to the micrometer. So you have the dimension here, and then on the ring you have here the last digit, the micrometer screw that you can see here. So it's a skill. And here at Jamong, they have very trained personnel that can do this. So when the dimension is critical, you want to have a checkpoint about this. 张先生，谢谢你。Before you go into mass production, you have to make sure that your part meets the standard. One of our clear processes to make sure that we are right is called first article inspection. And here, Mr. Long is using his 3D equipment to measure all dimensions that are in the drawing. Afterwards, we're not checking every dimension. But in the beginning, for the first part, for the first time coming out of mold, we do. And then from that report, we can make the judgment whether a mold has to be fine-tuned or it is acceptable to go into production. Now, we want to get to the real thing. And I want to ask Mr. Cheng, what typically goes wrong in production? 郑先生，你在量产的时候，常常发现什么问题？
温度
The temperature in the mold is not homogeneous, meaning there's a difference. Some area of the mold is hotter than in other areas of the mold. And this will lead to deformation. So now I'll ask him how he finds it and how he inspects it.
举例说，这个产品来讲，
For the first item, the temperature on the outside surface was not high enough, so there are a lot of sink marks on them. And on the other side, on this round one, in one section of the circle, it's different temperature than the other one. And then we can see it's not even. Now, even the mold is right, but your process is not right, or the temperature is not right, you still get a problem. So this clearly explains that you need to check that before you go into the next process. And now I'm going to ask him how he establishes the criteria to determine whether it's good enough.
初步的检验，
You see he has got these little parts that he can put underneath so we can establish a maximum thickness that cannot go underneath of this part. You have to possibly modify the mold or adjust the production parameters, making the cooling design right and making sure that the temperature is reasonably even. It's very important. Would you like to say something else to an engineer that is designing something where you should pay attention to?
在 弧面的制作过程
One of the key elements, and this is one of the lessons we can take out from here today, is to avoid a huge difference in wall thickness. So not to have too thick and too thin parts in the same, because pressure in the mold and the temperature cooling process will not be even. So when you make a design and you want to make a good die casting product, try to keep your wall thickness as similar as possible to get a homogeneous cooling process, therefore less deformation, therefore less trouble. Because again, we want to produce quality and not sort out unqualified parts. 谢谢. Thank you.
谢谢
So therefore, taking these measurement technology and doing a regular check on them is recommended. But again, focus on what matters in your product. And if you need help, we're happy to assist our clients at the early stage of this and also determine the initial verification measurements and also the in-process measurements to check on them. We have statistical processes, we have regular processes. We recommend a different cycle of measurements to reflect the risk that is associated with it. Anyway, I hope this video gave you some insight, and please feel free to reach out to us if you need help in this regard.